This is SpaceTime Series 20, Episode 59. Coming up on SpaceTime. Lunar water more common than previously thought. Dark matter more likely to be cold rather than fuzzy. And countdown to Cassini's grand finale. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
There could be a lot more water on the moon than previously thought. New satellite readings indicate that numerous volcanic deposits spread across the lunar surface contain unusually high amounts of water compared with surrounding terrains. The findings, reported in the journal Nature Geoscience, mean there could be as much water in the lunar mantle as what there is in mantle basalts found on Earth. And all that raises some really serious questions about how the moon was formed. The lunar water is trapped inside tiny glass beads, formed through explosive eruptions of ancient magmas from deep within the lunar interior. Scientists had always assumed that the interior of the moon would be largely depleted of water and other volatile compounds. However, that picture began to change in 2008, when researchers discovered trace amounts of water in some of the volcanic glass beads brought back to Earth by the Apollo 15 and 17 lunar missions. Then in 2011, a further study of tiny crystalline formations within the beads revealed they actually contain similar amounts of water to some basalts on Earth. And that suggests that the moon's mantle, at least parts of it, could contain as much water as the Earth's mantle. The new study's lead author, Ralph Millikan from Brown University in Providence, Rhode Island, says the key question now is whether those Apollo samples represent the bulk conditions of the lunar interior, or whether they're just some unusual anomalous water-rich regions in what is otherwise a dry mantle. By looking at the orbital data, the authors were able to examine large pyroclastic deposits on the moon's surface, which were never sampled by either the American Apollo or Soviet Union lunar missions. The fact that nearly all of them exhibit signatures of water suggests that the Apollo samples are not anomalous. And that means the bulk interior of the moon could be wet. To reach their conclusions, the authors used satellite-based spectrometers to study the light bouncing off the lunar surface. By looking at which wavelengths of light are absorbed or reflected from the lunar surface, scientists can get a pretty good idea of what minerals or other compounds are present. However, there is a problem. You see, like Earth, the lunar surface heats up over the course of a day. And it just so happens that the latitudes which heat up the most also happen to be the same latitudes where these pyroclastic deposits are located. So that means in addition to the light being reflected from the surface, the spectrometer is also measuring heat. And that thermally emitted radiation just happens to be at the same wavelengths as that needed to look for water. In order to resolve the problem, the authors first needed to account for and then remove the thermally emitted component before they could measure the water component. They achieved this by using laboratory-based measurements of the actual samples returned from the Apollo moon missions. They then combined that with a detailed temperature profile of the areas of interest on the lunar surface. Using the new thermal corrections, the researchers then looked at data from the imaging spectrometer which flew aboard India's Chandrayaan-1 lunar orbiter. Amazingly, they found evidence of water in nearly all of the large pyroclastic deposits that had been previously mapped across the lunar surface, and that included deposits near both the Apollo 15 and 17 landing sites, where the water-bearing glass bead samples had been collected. Because these same water-rich deposits were spread right across the lunar surface, it means that the water found in the Apollo samples weren't isolated instances. It means lunar pyroclastics seem to be universally water-rich, and that suggests the same may be true of the mantle they originate from. Of course, the idea that the lunar interior may be water-rich raises some interesting questions about the moon's formation. According to the well-accepted giant impact theory, which is favoured by most scientists, the moon was formed 4.5 billion years ago when a large Mars-sized planet collided with the proto-Earth. That collision turned both bodies into a magma ocean. Debris flung out from the impact formed a ring around the Earth, which eventually coalesced to form the moon. One of the reasons scientists had always assumed the moon's interior would be dry is that it seems highly unlikely that any of the hydrogen needed to form water could have somehow survived the heat of that massive impact. Of course, the growing evidence for water inside the moon suggests that water did somehow survive. Either that, or more likely it was brought in shortly after the impact by asteroids and comets, but at a time before the moon had completely solidified. And of course the same could be true for the other member of the Terran system, planet Earth. In addition to shedding new light on the water story in the early solar system, the research could also have implications for future lunar exploration. While the volcanic beads don't contain a lot of water, only about 0.5% by weight, the deposits are large, and that water could potentially be extracted. Other studies have detected hints of water in the permanently shaded floors of impact craters near the lunar poles, in those deeply shadowed areas that would never receive direct sunlight. But the pyroclastic deposits may be at locations which may be easier to access for future lunar missions setting up bases there. And of course that would help future lunar explorers, saving them from needing to bring lots of water with them, not just for drinking, but also for converting into oxygen for breathing and for splitting into fuel for energy and propellant. This is SpaceTime. I'm Stuart Gary. Scientists trying to understand dark matter now believe it's far more likely to be big and cold rather than light and fuzzy. Even though it's invisible, scientists know dark matter exists because they can see its gravitational influence on the stuff around it. The problem is, even though there's 5 times more dark matter than normal matter, scientists still have no idea what it is, making dark matter one of the biggest mysteries in astronomy and physics today. For decades, theoretical physicists have tried to understand the properties of the particles and forces which make up dark matter. And there are numerous hypotheses to try and explain it. These range from new as yet undiscovered particles, to virtual quantum particles that are constantly popping into and out of existence, to undiscovered populations of neutrinos, and even undiscovered primordial black holes. The new findings, reported in the journal Physical Review Letters, are based on a study of the intergalactic medium, the stuff that fills the vast, largely empty space between galaxies. The results will help scientists narrow down their efforts to detect dark matter directly by letting them know what they should be looking for, especially if researchers have a clear idea of what sorts of properties they should be seeking. The findings cast doubt on one relatively new theory for dark matter, known as fuzzy dark matter, and instead lend extra credence to a different model known as cold dark matter. Cold dark matter is the older of the two theories, dating back to the 1980s, and is currently the standard model of dark matter agreed to by most scientists. It suggests dark matter is made up of relatively massive, slow-moving particles with weakly interacting properties. As such, cold dark matter helps explain the unique large-scale structure of the universe, which is why galaxies tend to cluster together in larger groups. But the cold dark matter theory also has some drawbacks and inconsistencies. For example, it predicts that our own galaxy, the Milky Way, should have hundreds of small satellite galaxies orbiting around it. The problem there is astronomers have so far only found about 50 satellite galaxies with the nearest 1.4 million light-years. The newer fuzzy dark matter theory addressed the deficiencies of the cold dark matter model. According to this theory, dark matter consists of an ultralight particle rather than a heavy one, and also has a unique feature related to quantum mechanics. For many of the fundamental particles in our universe, their large-scale movements travelling distances of meters, kilometres and beyond can be explained using the principles of classical Newtonian physics. However, explaining small-scale movements, such as at the subatomic level, requires the complex and often contradictory principles of quantum mechanics. And that's where the problem comes in. For the ultralight particle predicted by fuzzy dark matter theory, movements at incredibly large scales, such as from one end of a galaxy to the other, also require quantum mechanics. To resolve the issue, the authors of this new study have drawn up both fuzzy and cold dark matter theories to try and explain the effects dark matter appears to have on galaxies and on the intergalactic medium between them. The study's lead author, Vid Erzik from the University of Washington, says his research has now placed constraints on what dark matter could be, and fuzzy dark matter, if it were to make up all of the dark matter, would be inconsistent with that data. Erzik and colleagues set out to model the hypothetical properties of dark matter based on relatively new observations of the intergalactic medium. The intergalactic medium consists of largely dark matter, whatever that may be, along with hydrogen gas and small amounts of helium. The hydrogen within the intergalactic medium absorbs light emitted from distant bright objects, and astronomers have studied this absorption for decades using Earth-based instruments. For their study, the authors looked at how this intergalactic medium interacted with light emitted by quasars, which are distant massive energy sources generated by feeding supermassive black holes. One set of data came from a survey of 100 quasars by the European Southern Observatory in Chile. The team also looked at observations of 25 quasars from the Las Campanas Observatory, also in Chile, and from the giant 10-metre Keck twin telescopes in Hawaii. Using a supercomputer at the University of Cambridge, the authors simulated the intergalactic medium and calculated what type of dark matter particle would be consistent with the quasar data. They discovered that a typical particle predicted by the fuzzy dark matter theory would simply be too light to account for the hydrogen absorption patterns seen in the intergalactic medium. However, a more massive, heavier particle, similar to the predictions in traditional cold dark matter theory, would be far more consistent with their simulations. An ultralight fuzzy particle could still exist, but it can't explain why galaxy clusters form or answer other questions like the lack of enough satellite galaxies around the Milky Way. A heavier cold particle remains consistent with the astronomical observations and simulations of the intergalactic medium. Mind you, the team's results don't address all of the long-standing drawbacks of the cold dark matter model, but the team believe that further mining of data from the intergalactic medium will eventually help resolve the type or types of particles which make up dark matter. You're listening to Space Time. I'm Stuart Gary. As scientists continue to examine data from the recent Juno spacecraft flyby of Jupiter's iconic Great Red Spot, astronomers have used the infrared imager on the Gemini Telescope in Hawaii to study the solar system's largest planet in a new light, revealing particles over a wide range of different altitudes. The image was taken in collaboration with the scientists working on the Juno flyby. The multiple filters on the Gemini Telescope correspond to different colours used in the image over wavelengths between 1.69 microns and 2.275 microns. In the new ground-based images, Jupiter's Great Red Spot appears as a stunning bright white oval at these wavelengths, which are primarily sensitive to high-altitude clouds and hazes near the top of Jupiter's convective region. The Great Red Spot is a massive anticyclonic storm, a high-pressure hurricane that's been active for at least 350 years and possibly centuries longer. When first studied back in the 1800s, the storm was over 41,000 kilometres wide, some 3 times the size of the Earth. The latest measurements have confirmed that the Great Red Spot is continuing to shrink and is now only about 16,300 kilometres wide, although that's still far larger than the Earth. The new observations show that the Great Red Spot is one of the highest altitude features in the Jovian atmosphere. Narrow spiral streaks that appear to lead into or out of it from surrounding regions probably represent atmospheric features being stretched by the intense 600 km/h winds within the Great Red Spot. Some of these winds are being swept off the Great Red Spot's eastern edge into an extensive wave-like flow pattern. There's also traces of a similar flow from the spot's northern edge. Other features near the Great Red Spot include a dark blotch and an oval both to the south and to the north of the eastern flow pattern. These indicate lower density clouds and haze particles at those locations. Both are long-lived cyclonic circulations rotating clockwise, which incidentally is the opposite direction of the counterclockwise rotation of the Great Red Spot itself. The new images also show a prominent wave pattern north of the equator, along with 2 bright ovals which are anticyclones which first appeared in January 2017. Both the wave pattern and the anticyclones could be associated with an impressive upsurge in stormy activity that's been observed at these latitudes this year. Another bright anticyclonic oval was also detected further north. All 3 of these storm cells were imaged by Juno during its historic Great Red Spot encounter. The new Gemini images also show high hazes over both polar regions in far greater spatial structure detail than previously possible. You can check out the stunning new images on the SpaceTime blog. That's at spacetimewithstuartgary.tumblr.com, and that's Tumblr without the E. To find out more, Andrew Dunkley speaking with Dr. Fred Watson from the Australian Astronomical Observatory.
Let's talk about the weather on Jupiter, which has been spectacularly photographed, and the pictures are startling.
Indeed they are, Andrew. And I guess we're all used to seeing revolutionary, detailed images of Jupiter, particularly the poles of Jupiter, now that the Juno spacecraft is in orbit around the planet, which will be for a little while to come yet. But the image that certainly caught my attention this week, and And you're right about the psychedelic colouring. It's really interesting to look at. This is an Earth-based image, or an image taken from a ground-based telescope. In fact, one of the two Gemini telescopes. Gemini is a multinational project. They run two 8-meter class telescopes, one in Hawaii, one in Chile. And what they have done is used an instrument which is called NIRI, N-I-R-I, which stands for, well, you can probably guess it, Near Infrared Imager.
I wouldn't have guessed that, no, I'm afraid.
It's not near because it's near the telescope. It's near infrared, and near infrared is what we call short wavelength. It means it's not very far beyond what we can see, beyond normal red. Infrared, of course, is light that is redder than red. So what the Gemini scientists have done, and it's in fact the Hawaiian telescope that's done this, they've taken images of the planet Jupiter using this near infrared imager, taken separate pictures at different wavelengths. Now, what that means is essentially different colors, although it's a bit funny to think about colors for something that is in infrared and is actually invisible. But yes, infrared radiation has colors as well. So they've isolated 5 different colors in the infrared spectrum, and then they've formed a composite image from those. It's actually the same technique that my colleague David Malin pioneered back in the 1980s using standard color images with an optical telescope. He used to use blue, green and red filters and then combine the images taken separately through each of those in order to make a genuine true color image, one that we would see if our eyes were billions of times more sensitive. Well, the guys at Gemini have done the same thing, but with infrared. So what you've got is a color image of the planet itself, really showing quite startling colour differences. And the colour differences, while they look pleasing to the eye, are nevertheless telling scientists that different stuff is going on in these different regions of the planet Jupiter.
The thing that sticks out straight away when you look at the image is the big red spot, which is not a big red spot in this picture.
It's a big white one,
That's
right. So what that tells you is that it's sort of equally reflective in all the colour bands that the image was taken in, because it's turned out white. It's a neutral color. And what the scientists are telling us is that white is actually revealed by high altitude clouds and hazes right at the top of Jupiter's atmosphere. So if you've got these high altitude clouds in Jupiter's atmosphere, and remember Jupiter's a gas giant, we never see a solid surface, we just see the upper layer of the cloud deck. Things that are white in color are very near the surface of the atmosphere. As I said, high altitude clouds and hazes. And that tells you that the Great Red Spot, rather than being something deeply ingrained in Jupiter's atmosphere, which certainly is the way it looks when you get a standard color image of it, it's a very high altitude feature. What it probably is telling you, in fact, is that the Great Red Spot extends to very high altitudes. It probably penetrates really low down into the atmosphere. There's also some remarkable structure. I mean, this is a beautiful image that has been taken, considering it's a telescope on the ground. Gemini is one of the pioneering facilities for what we call adaptive optics imaging. In other words, taking the twinkle out of starlight, taking the distortion out that the atmosphere puts in by compensating for that electronically. And what you get is an image that essentially freezes the detail, very fine detail. And in fact, what you can see in this image is really delicate structure in the wake of the Great Red Spot, which of course is an anticyclone, basically a huge storm. It's bigger than the Earth, by the way. It's about 1.5 times the diameter of the Earth. It's been around for at least 300 years. People in the vicinity of Jupiter might well be wondering when this storm's going to give up and stop, but it hasn't done yet. And the other thing that I thought was very noticeable is a kind of orange glow near the poles of Jupiter, the North and South Pole poles. And we know that Jupiter, because it has a magnetic field that's thousands of times stronger than the Earth's, it generates aurorae. The aurora borealis and aurora australis are very bright on Jupiter. And apparently these high-altitude hazes that are causing the orange glow at the poles is the result of chemistry that comes from some of these auroral phenomena in the atmosphere.
Most amazing. And you mentioned David Malin, and I've seen a lot of his work, and it's really fascinating to think that something he developed over 30 years ago is still holding true in the technological world that we now live in. It's amazing.
It is. And actually, David deserves a lot more credit than he gets for the fact that he pioneered these techniques, which are now used by amateur astronomers all over the world to make photographs that really rival what we were producing on the Anglo-Australian telescope 30 years ago. And that's partly because of modern electronic detectors, of course, but it also speaks volumes for the prowess of amateur astronomers in the work that's going on these days. It's fabulous stuff.
That's Dr. Fred Watson from the Australian Astronomical Observatory, speaking with Andrew Dunkley on our sister program, Space Nuts. And this is Space Time. I'm Stuart Gary. If you want more Space Time, check out our blog, where you'll find all the stuff we couldn't fit in the show, as well as loads of images, news stories, videos, and other things on the web I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word and in lowercase, and that's Tumblr without the E. You can also follow us through @StuartGary on Twitter, @SpaceTimeWithStuartGary on Instagram, and on Facebook just go to www.facebook.com/Spacetime with Stuart Gary. After nearly 13 years in orbit around the ringed world of Saturn, Cassini is finally nearing the end of its journey. As part of its final chapter, the spacecraft's been performing a series of daring dives between the planet and its spectacular ring system, in the process providing unprecedented close-up views of the rings as well as Saturn's swirling cloud tops. Cassini's final dramatic suicidal death plunge into Saturn's atmosphere will occur on September the 15th. It was back in April when Cassini successfully executed its 127th and final close-up flyby of Saturn's moon Titan. That manoeuvre placed the spacecraft in its grand finale trajectory, a series of 22 orbits, each lasting about a week, drawing closer to Saturn and passing between the planet's innermost rings and its outer atmosphere. The first crossing of the ring plane happened back on April the 26th. With repeated dives into this previously unexplored region, the mission's concluding its journey of exploration by collecting unprecedented data to address fundamental questions about the origin of Saturn and its ring system. Cassini has never ventured into this area of Saturn and its rings before. It's simply been too dangerous. So these orbits really are like a whole new mission. Each orbit's inclined at 63 degrees with respect to Saturn's equator. They're providing the highest resolution observations ever achieved of both the inner rings and the planet's clouds. The orbits are also giving scientists the chance to examine in situ the materials in the rings as well as the plasma environment of Saturn. With its radio science investigation, Cassini's measuring Saturn's gravitational field as close as 3,000 kilometres from Saturn's upper cloud layers, greatly improving current models of the planet's internal structure and the winds in its atmosphere. Scientists expect the new data will also allow them to disentangle the gravity of the planet from the tiny pull exerted on the spacecraft by the rings, thereby allowing it to measure the total mass of the rings with unprecedented accuracy. ESA ground stations in Argentina and at New Norcia near Perth are working together with NASA's Deep Space Communications Network, which includes the Canberra tracking station, to receive Cassini's radio science data during the spacecraft's 22 grand finale tracking passes. These grand finale orbits are also probing the planet's magnetic field at similarly close distances. Previous observations showed that the magnetic field is weaker than expected, with the planet's magnetic axis surprisingly well aligned to the planet's rotational axis. The new data being collected by Cassini's magnetometer will provide fresh insights into why this is so and where the sources of magnetic field are located. Also, whether there's something in Saturn's atmosphere which could have been obscuring the true magnetic field from Cassini until now. While crossing the ring plane, Cassini's cosmic dust analyzer has been directly sampling the composition of dust particles from different parts of the ring system. At the same time, its ion neutral mass spectrometer has been sniffing the upper layers of Saturn's atmosphere in order to analyse molecules escaping from the atmosphere, as well as water-based molecules originating from the rings. Launched back in 1997 from the Cape Canaveral Air Force Base in Florida, the Cassini spacecraft embarked on a 7-year voyage across the solar system, eventually arriving at Saturn in July 2004. Several months later, Cassini released the European Space Agency's Huygens lander probe. Huygens successfully touched down on the surface of the mysterious moon Titan on the 14th of January 2005, the first ever landing in the outer solar system. Enshrouded by a thick nitrogen-dominated atmosphere, Titan has a weather and hydrological cycle which bears some interesting similarities to that of Earth. Huygens has revealed Titan to be an Earth-like world of flowing rivers and vast lakes and seas. We know there were recent rains at the landing site just before Huygens touched down because Huygens' feet were able to detect the wet sand. However, in the cold outer reaches of the solar system, temperatures on Titan reach minus 180 degrees Celsius, at which temperature water freezes so solid and hard it forms much of the moon's bedrock. So instead of water, on the world of Titan, the only liquids are methane and ethane. Combining the data collected in situ by Huygens with the observations performed by Cassini during flybys of Titan, the mission revealed the atmospheric processes of this moon and their seasonal evolution, as well as the surface morphology and the interior structure, which apparently also includes a liquid water ocean. The Cassini mission has greatly contributed to our understanding of the Saturnian environment, including the giant planet system of rings and moons. Over its 13-year mission, Cassini will have covered almost half of Saturn's orbit around the Sun, which takes 29 Earth years. This means the spacecraft's monitored almost 2 full seasons on Titan. Another of Cassini's breakthroughs was the detection of towering plumes of water vapour and organic material spraying far into the darkness of space from warm fractures near the south pole of Saturn's icy moon Enceladus. These salt-rich geysers are jetting into space from an underground sea of liquid water, which is looking only a few kilometres below the moon's icy surface. Gravitational and rotational measurements indicate this liquid water subsurface ocean could be many kilometres thick, and like the Jovian ice moon Europa, it could be global. A recent analysis of data collected during flybys of Enceladus by Cassini's ion-neutral mass spectrometer also revealed hydrogen gas in the plume, and that suggests that the rock may be interacting with warm water on the seafloor of the moon's subsurface ocean. Of course, this hydrothermal vent activity could also be providing a chemical energy source for life, enabling non-photosynthetic biological processes similar to the ones found near the hydrothermal vents on Earth's ocean floors, and thereby pointing to the potential habitability of Enceladus' subsurface ocean. Following over a decade of groundbreaking discoveries, Cassini is now finally approaching its end. With little fuel left to correct the spacecraft's trajectory, it's been decided to end the mission by plunging Cassini into Saturn's atmosphere on September 15, 2017. In the process, Cassini will burn up, thereby satisfying planetary protection requirements to avoid possible contamination of any moons of Saturn which could have the potential to harbour life. This grand finale is not only a spectacular way to complete this extraordinary mission, but it will also return a bounty of unique science data collected during its entry into the Saturnian atmosphere, which simply would not have been possible during any previous phases of this mission. I'm Stuart Gary. You're listening to SpaceTime. And time now to take a brief look at some of the other stories making news in science this week with the Science Report. A new study has found that 91% of plastics being produced worldwide aren't recycled. Mass production of plastics, which began over 6 decades ago, has now reached 8.3 billion tonnes, most of it ending up in landfills or as discarded pollution. The study, by scientists at the University of Georgia, was undertaken in response to the huge amounts of plastic trash that have ended up killing birds, marine mammals and fish. It's now predicted that the world's oceans will contain more mass in plastic waste than fish by the middle of the century. A new study has found links between some antibiotics taken during pregnancy and major congenital malformations in newborns. The study, reported in the British Journal of Clinical Pharmacology, examined 139,938 live births in Quebec between 1998 and 2008, finding several specific antibiotics linked to organ-specific malformations. The findings mean that while absolute risks for birth defects were small, doctors should consider prescribing other antibiotics when treating patients with infections during pregnancy. Male fertility in wealthier nations has seen a steep decline in sperm counts. The findings, reported in the Journal of Human Reproduction Update, is based on a review of data from 185 different studies, finding a 59.3% drop between 1973 and 2011 in the average amount of sperm produced by men in North America, Australia, Europe and New Zealand. Interestingly, similar patterns were not seen in South America, Asia or Africa, although far fewer studies have been conducted in these locations. The new findings support earlier claims linking the drop to chemicals in the womb, as well as adult exposure to pesticides, smoking, stress and obesity. However, the new research, which was conducted by scientists at the Hebrew University in Jerusalem, eliminates a number of concerns with earlier studies by including a large number of studies of varying designs from a wider spectrum of both communities and locations. A new technology may help to non-invasively analyse lung sounds in children and infants at risk of an asthma attack. In a study of 70 severely asthmatic children, the approach was useful for predicting attack symptoms and for identifying asymptomatic children at a higher risk of an asthma attack. The results are published in the journal Respirology. A new study has warned that permafrost soils in Arctic regions, which are thawing due to increasing temperatures caused by anthropological climate change, are having a double effect on greenhouse gas emissions. The findings, published in scientific reports, concluded that rising temperatures are not only thawing the permafrost, opening pathways for older stored geologic methane to escape into the atmosphere, but the higher temperatures have also sparked significant fresh microbial methane production closer to the surface. The new study examined a 10,000 square kilometre wide area of northern Canada, finding strong emissions wherever the permafrost had thawed. A report in the British Medical Journal has found that children exposed to antidepressants during pregnancy seem to be at a slightly higher risk of autism than children of mothers who weren't treated with antidepressants during pregnancy. Previous studies have reported associations between antidepressant use in pregnancy and autism in offspring, but it's been unclear as to whether this link was due to the underlying illness, the antidepressant drug treatment, or some other factor. To try and resolve the issue, scientists analysed data from some 254,610 kids and teenagers aged between 4 and 17, including 5,378 with autism. The subjects, who are all living in Stockholm between 2001 and 2011, were born to mothers who either did not take antidepressants and did not have any psychiatric disorder, mothers who did take antidepressants during pregnancy, or mothers with psychiatric disorders who did not take antidepressants during pregnancy. Of the children exposed to antidepressants during pregnancy, 4.1% had a diagnosis of autism. That compares to just 2.9% of children who were not exposed to antidepressants, but whose mothers did have a history of a psychiatric disorder. Depression is common in women of childbearing age, with up to 8% of pregnant women prescribed antidepressants during pregnancy. And finally for now, researchers have identified a genetic difference between domesticated dogs and wolves, which could explain the canines' contrasting social interactions with humans. The findings, reported in the journal Science Advances, provides a new understanding of the behavioural divergence between dogs and wolves which began thousands of years ago. It was once thought that during domestication, dogs evolved an advanced form of social cognition which wolves simply lacked. However, this new study suggests that, compared to wolves, dogs actually have a genetic predilection that can lead to an exaggerated motivation to seek social contact. Researchers evaluated human-directed sociability in 18 domesticated dogs and 10 captive human socialised grey wolves using sociability and problem-solving tasks. The dogs and wolves were given a solvable task with the person present, that task being to open a puzzle box containing a sausage within 2 minutes. The dogs were more likely to gaze at the person and not persist with the task. The wolves, on the other hand, were far more likely to persist with the task and solve it even if a person was nearby. The researchers then conducted a second test. They had a person sitting down inside a marked circle, either calling the animal by name and actively encouraging contact while remaining in the circle, or sitting quietly and ignoring the animal by looking down on the floor. Both the dogs and wolves quickly approached the people, but the wolves tended to wander away after just a few seconds, while the dogs persisted for a long period of time. The real difference seems to lie in the dog's persistent gazing at people and what appears to be a genuine desire to seek prolonged proximity to humans. I'm Stuart Gary. You're listening to SpaceTime. And that's the show for now. You can subscribe and download SpaceTime as a free twice-weekly podcast through iTunes, Stitcher, Bytes.com, Pocket Casts, SoundCloud, YouTube, Audio Boom, your favourite podcast download provider, or direct from spacetimewithstuartgary.com. The show's also broadcast coast to coast across the United States on Science 360 Radio by the National Science Foundation in Washington, D.C., around the world on TuneIn Radio, and as part of Virgin Australia's in-flight entertainment. If you want more SpaceTime, check out our blog where you'll find all the stuff we couldn't fit in the show, as well as loads of images, news stories, videos and other things on the web I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word and in lowercase. and that's Tumblr without the E. You can also follow us through @StuartGary on Twitter, @SpaceTime with Stuart Gary on Instagram, and on Facebook just go to www.facebook.com/Spacetime with Stuart Gary. Spacetime is brought to you in collaboration with Australian Sky and Telescope magazine, your window on the universe.
You've been listening to SpaceTime with Stuart Gary. Subscribe at iTunes, Stitcher, Pocket Casts or Audio Boom. This has been another quality podcast production from Bytes.com.